Okay, right, so we're carrying on. So, unfortunately, there aren't too many of the types of vectors questions you've been doing up until now in the exams. Often they tend to be more akin to these kinds of things. So, here is a diagram. We've been told that vector x, as you can see, goes from this measurement to this measurement. Okay, so it goes from here to here. Vector y goes from here to here. So what they're doing is they're asking you to use your understanding and knowledge of a hexagon, okay, a regular hexagon of that, to be able to define some other vectors. So they want you to express the vectors ED, DE, and so on and so forth in terms of x and y. So what we do is we say, right, well, where's E and where's D? Okay, so E is here. E is here, so we want to move from E to D. Can anyone suggest what vector or how we might describe that movement? Does it look like anything to do with either X or Y? Does it? Can we see it looks very much like the movement that X made? Yes? And that's it. We would describe E to D as hook X. That's it. Okay? Because it's made the exact same movement. It's parallel to it because we know hexagons, a regular hexagon, these lines would be parallel and they are the same length. Okay? Yeah, you should have a squiggly line under it just because you can't fold something. Right, that was nice and easy, yes? She said it's complicated. What about DE? So obviously same two letters, but this time we're going the opposite direction. What do we say when they're the opposite direction? Minus. Minus, yeah, so it'd be negative x.
Wait, you wouldn't say that it's y?
No, because remember y goes in this movement, okay? So y is anything that goes like this direction. X is the only one that goes like that, yeah? I thought we'd do colours to help you here. The blue, I just showed you the blue one, so the D goes to the E.
I mean the arrow on top of it.
Oh, that tells you where to, which letter to spell, which letter to finish.
So you couldn't just do the arrow there.
You could, but it's not normally done like that. But you're right, you could. I would suggest that they wouldn't normally because I think doing that arrow typing is hard. I think it's easier to get that simple. Realistically. Okay, FE. Okay, so where's F to E? So F is here, E is here. What's that vector? Y. Oh, you lot, you're just on top of the ball. Oh, now, here we go. A to C. A to C. Okay, so A is here and C is here. Now, with these types of situations, you can only follow the path of something that's labelled or a vector that you can identify, okay? So I can't just go across here because there's no vector line that way.
Is it x, y?
Almost.
X plus y.
X plus y. Yes, I'm loving it. Yes. That makes sense, yes? You're the one that told me. Well, yeah, but you said X, Y, same thing. Okay, FA. Okay, so we're established. I've drawn all over stuff now. Right, F to A. Ooh, okay, this is a slightly tricky one. So we're going from F to A. So remember, we have to follow the path of something that we know or something we can identify. So, would I go round the houses like this? Probably not. I would suggest we'd probably go in this direction. So what would we describe that as? X. And then probably this direction. Careful. Negative Y, because it's going the opposite direction, yes? So this would be an X minus a Y. Who was going, ah? Oh, that was harsh. Okay, so y goes from here to here in that direction. Yeah.
Yes.
And so if I was starting here and going in this direction, it's the opposite way, yes?
Oh, yeah.
So you can see it's the same vector or equivalent
I just
vector.
realized that's like the top of the box, right?
Roger that. Huh? Are you just talking to yourself?
Yeah.
Roger that.
So it's a hexagon with lines in it. It kind of looks like a cube. Yeah.
Oh, no, don't start doing that because then people are going.
But is it not
"Oh,
a cube? It's a hexagon.
No, it's a hexagon.
I've been looking at it like a cube.
Oh my God. Now someone said that.
Yeah.
I'm sorry. Everyone.
No, it actually It's okay. 2D, not 3D. It's 2D.
You obviously have a 3D head.
Oh,
now I'm also. I'm not.
It's
not. I'm not. It's just one of those impossible. You know, not impossible. You know those. Is it a lady's face or is it an old man? Kind of.
Wait, I just thought easier to look at. Yes, it is. And you can see like.
Is that it? Well, the important.
But it's just.
All right, everybody. Anyway, she's got no control. To be honest, it wouldn't really matter how you picture it, as long as you identify that these lines are all parallel to each other and that they're all the same length. Okay, so I mean they have told you it's a regular hexagon, but if your visual goes to 3D solid, as long as you are appreciating that they are parallel to each other. Yeah. And last one, A to E. Oh, now I can't even see where all the legs are. Okay, A to E. So starting up here and going down here. So what would we do?
Negative 1? No.
Well, okay. I'm gonna go 3. You could go any movement you like, but I would probably go down to here and then this way.
Can you do 3 movements?
You can totally do as many as you want, but then you would join like turns as well, like vectors. Yeah?
How come you can go all the way A and then B to B?
Because I'm gonna ask you, how would I describe that? So if I started here, I got to here, that would be Y, and that's another Y. So what would we call that?
Oh, that's Y.
Well, yeah, because they're parallel, yes, and the same
2Y.
name. So that would be 2Y, and then this is going the opposite direction of X. So that would be 2Y minus X. Okay. Now, if you've gone in some other movement, so for example, we've just worked out what FA was, yes? So we could go A to F and then F to E. So that would have been the opposite to this. So that was negative X plus Y. And then one of these, that was another Y. And you'll see that, look, that simplifies to give you 2Y and a minus X as well.
How is it negative X?
Because we're going the opposite direction of X.
No, the second one that you did.
Because X goes from here to here, and I went.
So it's not
Oh,
necessarily.
the second one? Oh no, because I followed this path,
Yeah.
and so I did the opposite to this, negative X plus Y.
Okay.
Yeah. Are we all good?
What's that line in the middle equal to though? Like if you wanted to do A to E. Oh wait. I would like A go down the middle, like A and
Well, you would identify that that's equivalent to this one that we just worked out.
okay.
Yes.
So X. That line.
A to F would be the same as O to E. Is that what you're talking about?
Yeah, but like what is that? Y or X?
It's not. A to F would be the opposite of this. Okay? So with any of these, you just have to follow the movement of the vectors that you know. Does that all make sense? Yeah? Ooh,
The line. There's so many others as well.
the line of
You
the
just do it randomly?
Do you mean this? Just try and do it. Oh, it really wouldn't, like, and if you didn't have it, it's not the end of the world. That wouldn't be something that they'd pull you up on. If you forget it, it's not the end of the world. Okay? Right. As I said, often they'll just throw little words in there, and if you've got no clue what a rhombus is, then you're in doo-doo. Okay? What's special about a rhombus? They are parallel sides, but what's also special?
Two sets? I don't know. I don't know.
Huh?
No one knows what
I always look at
Hannah and Hannah,
same line.
they're all the same length. Okay?
Every line.
So a rhombus is a wonky square. Okay? These are actually all the same length. Now, they may well put a little Ujima what's it here, saying not drawn to scale. Okay? So you just have to appreciate that, but a rhombus has all sides the same length. Okay?
Whichever is the shape of the
Yeah, so that would just be a straightforward parallelogram. So a rhombus is a parallelogram because it has two pairs of parallel lines. Okay? But a rhombus particularly has all four sides the same. Okay, so that's going back to probably year 8 or 9 when you were taught all the properties of quadrilateral. So this is the thing, we do draw in all this information that you've learned previously and just expect that you're going to remember that. Okay, so whilst it's a vectors question, you have to know what's special about rhombus. Oh, good evening. Oh, just slip it there like this. And there's your usual what's it? Yeah. Alright, A, B, C, these are rhombus. Find B to D. So here, you can see X is going from here to here. So which other movement would be described by X? D to C, love it. And Y is going from A to D. What other movements? B to C, lovely jumping. Alright, so B to D we want to go. Okay, B to D. Remember, we've got no labels along that line. So we have to follow things that we've been labelled, that have been labelled. So how would you start at B and end up at D? Oh, you lot are just awesome. B, so we're starting now at B, and we're just going to to E. Oh, here's another thing. Well, these lines here, do we know what's special about these lines? These diagonals, they are 90 degrees, but what's also special about it is that they bisect these bad boys. Okay? So they actually cut those in half. Okay? What did we just say? Alright, so yeah, so this cuts it in half. So from B to E is going to be what? Can someone describe just in words what it is?
Half of A.
Half of,
Like an inverse one.
yeah, it's half of B to D, yes? So next write is half of B to D. But we just worked out what B to D was, didn't we? So it's going to be a half of minus X plus Y. Jada, what's up? From
I don't know.
B to E is half the distance, yeah you could. It's half the distance from B to D, yes?
Yeah.
So it's half of BD. We just worked out what BD was. So we're literally just putting a half in front of what we had here.
Okay.
Yeah?
It's really small. I'm stellar friends.
Okay, obviously you could have minus a half X plus minus a half Y, anything like that. So these work in a similar way to algebra would work. Okay, so C, what's C? A to C. A to C. Well, so we need to get from, from here to here. We've got a couple of options. Which way do you want to go? This way or this way?
The first way.
This way?
Second way.
Oh, send me different grade. Okay, I shouldn't have asked. Okay, so we're going here and then here. So that's positive X, yes? And then
Y.
positive Y. Oh, trivia. Oh, I don't
Wait, can't you put
that's
some blue line under the whole thing? It only has to be that.
should be the separate ones. Really, we're very worried about squiggle.
I don't even know
Like,
what's that for. It's yellow line.
because remember I said that normally it would be bold. Well, you're not going to spend 20 minutes making all your letters bold.
Why would the letters be bold?
Because that's how we show it's not just an A, it's a vector.
Wait, can't you just make it bold by kind of going over the lines?
But what's the point?
When you can just
When you can just do a quick squiggle, it really doesn't matter. If you don't write it, it's not the end of the
Why not write it? Because like doesn't.
Or could you do
little song.
I can't not write it because I've been trained to write it. It's like saying, can you not just call me Ella because, like, just call me Mook? Because I don't want that first little bit off.
It's a longer for like a funny square.
Yes.
AC is so
AC. Is the same as what?
BD.
No, because they're perpendicular to each other. So, because it's wonky, so if it was an actual square, those diagonals would be equal. But the square's been tilted.
Okay.
So, we know they're the same length as all these sides are the same length. Okay? But because it's been twisted, the diagonals are no longer equal. Okay? Plus also, yeah, shut up. Okay, D. That was a shut up to me, obviously, not you. A to E. Who is E? Why do you not have a bit? Oh, God.
Just for a minute.
Okay. A, yeah.
Half of A to C.
Oh, my giddy aunt, you are O for awesome. Half of A to C. We just worked out A to C, so this is going to be a half of X plus Y. Oh, crazy.
Figured out A to C.
So here we go.
So now you can go A to C.
All right, okay, so these ones often throw people into a little bit of a loop. Okay, it says here, so here's a diagram. We can see where X is, yes, we can see where Y is. They've told us that A to M to B, so this is ratios, is in the ratio of 1 to 2. Okay, so for every one movement from A to M, there's 2 movements from M to B. Okay, now, sometimes people say, well, that's a half and that's a half thing. Not so much. So if it's in the ratio of 1 to 2, there are 3 parts in total, yes? So what we've done is we've cut this into thirds. So from A to M it's 1/3, and from M to B would be 2/3, okay? So when you see something like this, and as I said, these things do come up, and so they do try and just throw a quick ratio aspect to it. So just remember that ratios, you're looking for the total number of parts. Okay?
So it matters if you put the fraction or not, just like 2 to like.
Well, it will be because that's going to come into play in a second.
Did you say M to the second dot is 2 ends?
Yes.
Or the second dot to the B?
M to the B. Sorry, I just said yes, and then I said something different tonight. Because I just realised what you actually said the first time. Okay? Okay? I'm going to erase the dots because that will help concentration. Right, so we're finding it from A to B. So from A to B, we don't know the movement there, but what do we know? We can go along these paths. Oh, OMG, we are rocking and rolling. So that's A to B. Now here it comes into play that we want to just go from A to M. And so that the whole process of the fact it's how much of this line is it? It's 1/3 of it. So this would be 1/3 of minus X plus Y.
Why is Y?
Here, because A to B was minus X plus Y, yes? And A to M is 1/3 of A to B.
So we're assuming that A to O and A to B is the same split. Am I missing something?
Yes. From A to O and from O to no. Because we like we just did here. We knew that here to here was an amount. But you told me for this one it was a half of A to C, yes?
Yeah.
Same kind of principle. So we've just worked out from here to here. And so from here to here it's 1/3 of that.
Oh, I'm looking at the wrong thing.
Roger that. Okay?
Okay.
So A to M, so that's 1/3 of A to B. Does that help? Right.
Yeah.
Perhaps I should rewrite it somewhere else. Okay, from C to M. C to M. Where's C? Oh, so, oh my gosh, it's not a C. From O to M. From O to M. Okay, so what we're going to do, we're going to start here, we're going to go along here, so that's going to be Y. And then we're going to go up to this bit here. Okay, so this is going in the opposite direction of A to B. Are you with me? So we're going the opposite direction of A to B, and we're only going to go 2/3 of the direction. So actually, secretly, I want to change this to be A. Minus 2/3 of, I'm going to write AB.
Yes.
How about that?
I go the other way.
Why not go the other way? Oh, all right. Well, say meat different gravy. Would you? Okay, hang on a minute. All right. So that's a good question, though. Would most of you go that way?
Yeah.
I know.
Yeah.
I'll do both. Shall I do both?
Yeah.
You can show that they're the same. That's funny, isn't it, though? People would go different ways. Okay, but do we appreciate this one? So we've gone along Y, and we've gone the opposite direction 2/3 of the way of AB.
How many opposite directions?
Because it's going from B towards A.
What's that opposite?
A to B.
How do we know A to B is that way then? Because it's the first question.
Sorry, my facials are too much. I'm not sure what you mean. Like, from A to B means you start at A and go to B, doesn't it?
Okay, so like, can we just draw an arrow on there, I guess?
Sure.
I got it.
Please, don't encourage her. What do you mean, little?
Why would you start from A to B if you're going Y? You get to B first.
No, because that's here.
Yeah, and we went along Y.
Yeah, no, that's why I've got minus.
But why did you just put B to A?
All right, okay. All right, okay.
Because there's no arrow drawn.
Oh, wait.
So that A, that this, it goes to.
Do you prefer that?
Yes.
Okay.
No.
Oh, wait a minute. So that's going to end up being Y plus 2/3 of X minus Y. Okay? Because B to A is the opposite signs.
That made less sense.
Right.
Now we know.
Yeah, we will go the other way in a minute. But let me just prove this one.
What's the other way?
We're changing 16 times here.
B to A.
What?
B to A. I still don't really understand how B to A is backwards. Like,
No. Okay. Emma. If A to B, which we worked out for A, was minus X plus Y, then B to A would be X minus Y.
because it's opposite.
Oh, I know it. Yes. Okay. Yes. Good. So now I've got Y plus 2/3 X minus 2/3 Y. Okay. Remember I said that.
But you have to expand that?
Yes. Okay. So here we have to join stuff together. Okay. So we've got Y plus 2/3 X minus 2/3 Y. Now we can join these together as though they're like terms. So we've got 1Y, take away 2/3 Y. What are we left with?
1/3.
1/3 Y. I love it. Plus 2. Oh, here we go.
Don't you multiply like y plus 2/3 with the bracket? So shouldn't it be like y times x? And then 2/3 times x and then y times minus y and then, you know, when you expand, you multiply.
Darling, if I had this, what would you do?
3x plus 3y.
So what? It's a fraction. That's no different.
So y times x is xy.
Why are you trying to Y?
Because it's not outside of the bracket.
No, this is a separate term.
Oh,
Okay, it's not in a bracket.
okay.
Yes? Sure?
I missed something.
Because lots of people do that too.
I missed
Something.
How do you get the Y? Why did the Y change?
Because here I had 1y, take away 2/3 y. And that left me with 1/3 y. Now, let's be honest though.
Thank you.
This kind of question is probably at least 2 marks. I'd hate to break it to you, it probably is just 2 marks though,
For
okay?
A, B, and C.
For C. So C would be worth 2 marks, okay? So if you got as far as something like this, which I think is very doable, you'd be at least 1 mark, okay? You don't have to get 100% to get your grade 9, okay? So you can afford, if this is just doing your head in and exploding it, don't stress too much, okay? But as long as you can appreciate this bit, we're good, okay? I mean, I'd love it if you could do this, and you're all capable of doing this, but if the whole what on earth you're doing and the expanding is confusing you, then don't do it. Okay, let me go the other way now. I promised I would go the other way.
For the Y, it was 1.
1 whole one, subtract 2/3.
We said,
Because I have a secret one here. So because we're subtracting thirds, we change this to be 3/3. We can do we can make that anything as long as it's set on top of it.
that makes sense. Yeah, no, it makes sense.
And right, I promised I'd go the other direction because that's what people wanted to do. So if we want to go, no, we want to go from O to M. So here we're going to go this way. So that's going to be X, and then that's going to plus a third of. Oh no, we already did A to M. Okay, so that was X plus A to M, which we just worked out earlier. Crispians? Which I kind of agree does.
Wait, then that's it?
No, we've got to expand it all out. So we've got X, and then we've got minus a third X, and we've got plus a third Y. So then we've got 3/3 X minus 1/3 X is 2/3 X
Can you go back?
plus 1/3 Y. And lo and behold, it's the same answer.
Just everything is 1. Wait a second.
Wait a cotton picking minute.
Why does A to M have a Y in it?
Why does A to M have a what?
A Y in it.
Because we worked out A to M earlier.
Okay, why does it have a Y in it?
From A to M, we had to go minus X
Oh.
plus Y, and it was a third of it, remember? Yeah? Oh no, I don't know what that grimace means.
I just don't know why I didn't go straight there.
Because we did, this has not been, this wasn't labelled, remember?
Yeah.
So we first of all found a label from A to B, and then we established that from A to M was 1/3 of that. So that's 1/3 of that, yeah? I mean, as I say, I'll hold my hands up. O to M is much better to do this plus X. So I would suggest red label is better. But to me it only makes sense because we've worked out these prior. I think you got 6 short of me. Stop TikToking.
1 second.
It's spreading. You didn't, you had a quick quiz.
So that's it?
That question, yeah? Stress me out. I've just been asked to wait, so I'm waiting.
We can continue.
Merci.
Thank you. Ready?
Alright, given that U is blur, V is blur, and W is blur, simplify and express U plus V plus W. U plus 2V
So annoying.
blur, blur. Because these are the super straightforward ones, please. Okay, U plus V plus W. So we've got 1, 2 plus -4, 3 plus 2, -5. It's my job to go through different types of examples of questions you're going to have. I'm not writing the real thing, so don't moan at me because they ask me stuff like this. Or I'm just trying to help. What did we say that we did when we have this situation? We just add the top numbers and then we add the bottom numbers. Oh, pardonnez-moi, Emily.
Wait, what? Oh yeah, because 5 and 1. Minus 1. Because 3
See, it helps that she's not writing anything. She's just doing the calculations for us.
It looks like a winky
Good job, Emily. All right, next one. U plus 2v minus 3w. So U is 1, 2. What do you mean, whoa? That was the easy one. 2v minus 3w. Okay, so when the big numbers are in front, remember what we're going to do with the numbers inside the brackets? Multiply. We multiply both of them. So don't think of this like it's a whole number and you only multiply the top. You're multiplying both of them. Okay, so let's simplify it first. So it's 1, 2 plus negative, oops, I can't multiply. Negative 8, 6. Plus, oh, minus.
2 times 1, 2, and 2 times 2, 4.
Oh. Pardon? That's a 15, by the way. I know it doesn't look like it. Alright, let's not pick on it. Yeah.
Is that like the second
This is this one.
Wait.
Oh, now I don't know what happened there. What do you mean?
It's positive 15.
Oh no, I haven't done. I have my negative's still there. Look.
It's negative 6.
No, people. It will be. People. All I've done is do the 3 lots of this and the 2 lots of this. My sign here, negative sign here, is still there.
But could you like?
You could multiply by negative 3 and change that to a plus. Totally. Yes?
Wait, so that
Totally.
could be a 15 and a plus?
This could be a plus sign and this would be minus and this would be plus. Yes.
Oh. Minus 3 times.
I'm believing you, Emily. What did you say?
Yeah. Which way do you recommend?
Whichever you want.
So it could be.
But okay, my only thing is that I've seen in the past people write a minus here because that's what it's written, and then they go, oh look, it's negative 3, so they end up doing the negative twice and then messing it up.
Would have been twice.
So they would write 1, 2, negative 8, 6, minus, and then they'd write minus 6, positive 15. And so this negative is affecting it again, which it mustn't. So if you're gonna multiply it by negative 3, then you must change that to be a plus. Otherwise, it's going to go wrong. So you know yourselves which you're more likely to do. I don't know. And then the last one, similar situation. So this is 3u minus 2v minus w. Okay, so that's 3, 6 minus 8, 6 minus. Oh, shush now. Oh, I'm not good now. I don't want to write it anymore. I'm just stopping. What's the answer, Emily? I'll write it here.
How can you get
3 minus 8. And then we're minusing 2. So it's 9. Oh. I didn't just do that. I'm not minus 9. I thought it was might write properly here, but no, it's just written in the middle of the first thing.
Minus 2.
Okay, I'm going to stop this before I want to cry. What's the next page talk about?
What's this? 9 over 5.
Oh, there's more of them.
Wait a minute.
Yay! I want you to practice some stuff though for 15 minutes. Why don't you?
There's one here.
I'm trying to stop it.